Greetings and welcome, friends! We're taking a look at multiplying and dividing rational expressions on page 566. 76? 566, I don't know, something like that. 566. Here's problem 19. We were asked to simplify this. The thing I'd like to point out about this problem, I would try to factor everything before canceling anything out. And one of the things I want to point out, this would be super illegal. You cannot start canceling until you have factored. All right, and then even so, you can only cancel out an entire factor with another entire factor. So I believe 5x minus 5, I could steal a 5 out of both of those. So that's 5 times x minus 1. X squared minus 1, that is a pattern, friends. A squared minus b squared equal to a plus b, a minus b. You know what I'm saying? You know what I'm saying. Sum and difference of squares. So that's going to be x plus 1 times x minus 1. And now I can cancel. Fruit Ninja. Whooshing, whooshing. And I get 5 over x plus 1.
Where is the I didn't see the
a squared, x squared minus 1. 1 is a perfect square. You could think that is 1 squared. Yeah, so that's pretty cool. So that also would have worked if that was like a 4 or a 9 or a 16 or a 25, things like that. You know what's up. You know what's up. Let's take a look at another problem, 25. Here I'm dividing two things, all right? And instead of dividing, we said we should multiply by the reciprocal. You just flip and multiply. Guys, could you just for once flip and multiply? Seriously, this is ridiculous. So 2x cubed y over x to the 5th, multiply by the reciprocal. That's a z, that's not an x. Thank you, good catch, good save, z to the 5th. Multiply, and actually I might distribute this exponent to everybody as I'm flipping it. By the way, a negative raised to an even power, what's the sign of this going to become? Positive. So in my numerator, let's see, so I'm flipping it. Flip it like a spatula. Here we are. Z to the 3rd squared is z to the 6th over 4 squared is 16, x squared y squared, right? So now that I've got this set up, I can use some cross-cancel techniques if you're interested in that. I might use yellow this time. Between 2 and 16, 2 goes into those. 2 goes into 2 once, into 16 8 times. Between x squared and x cubed, I could cancel out 2 of these x's with 2 of those, leaving 1 behind. Between the y's, this y could kill 1 of those y's, leaving 1 behind. And between the z's, z to the 5th cancels out with 5 of those z's, leaving 1 behind. So now we can just multiply across and see what we get. So let's see, up top my coefficient 1 times 1 technically is 1. I've got an x to the 1st, z to the 1st hanging out. So x, not y, z, over, down on bottom I've got 8 and y. So I believe that should be our answer. All right, so once you simplify your factors, etc., you can just start canceling it out. Now in this case, I wasn't that worried about this because there's no plus or minus signs, so the actual factoring wasn't as much of a concern for us, right? But if this was like x plus y squared or something, like bam, once that happens, you got to really start being careful. So let's take a look at our last problem. Here's problem 33. This one's for reals. So I'm going to flip and multiply again. So I'm going to flip and multiply, and I'm going to try to factor all of this. All right, so let me just summarize my strategies here. Oh, wow, this one's actually doubly factorable for this numerator. This one's a GCF. I'm going to factor out a 3, and then in a moment you'll see that I'll have a difference of squares as well. This bottom I'm going to GCF, and then I'll probably be able to AC it, or not AC it, but just plain old factor it. This one looks like a GCF. Actually, all of these are GCF, so I'm going to have that as my starting move, just GCF everything. So factor out a 3 of that top, I'll have 3 times x squared minus 1 over, factor out a 2 here, I'll have 2 times x squared plus 4x plus 3. I'll be right there. For this one, factor a 5 out, but that one's now in my denominator. So I'm going to have 5 over, out of, let's see, x squared minus 2x plus 1. And here I'll factor out a 4, so I'll have 4 times x plus 3. So let's see, what do I have left to factor? This one is an a squared minus b squared. This one, I'd find the factors of 3 that add to be 4, and I found them. This one is actually a pattern. A squared minus 2ab plus b squared is equal to a minus b all squared. Or this one, you also could have just found the factors of 1 that add to be 2, and that would also work. And this is already fully factored. So let's take this one last little bit of the way. 3 times x plus 1, x minus 1. Difference of squares pattern. Actually, I can even write this all as one Gimondo fraction. Times 4 times x plus 3. This one is 2 times, that's going to be an x with a 1 times an x with a 3. And their signs are going to be plus plus, because they have to multiply to be 3 and add to be positive. This one I've got the 5 hanging out here. And this one's going to factor to be x minus 1 all squared, I believe. All right. So now this is going to be a good old Fruit Ninja right here. I can't wait. Oh yeah, sound effects coming at you. It's going to be great. I'm going to use yellow again. Sometimes I use red, sometimes I use yellow. Let's start Fruit Ninjing this. Let's see. 2 goes into 2 once, into 4 twice. Bam. X plus 1, x plus 1. Swing, swing. And let's see, x plus 3, x plus 3. And x minus 1 cancels out with one of these x minus 1s, leaving one behind. So let's multiply across. 3 times 2 is 6. And actually, oh, there's nothing left up top. It's just that. Over 1 times 5 is 5 times one of the x minus 1s. So this, I actually like leaving our answer in factored form. Technically, you could redistribute it once you knew you had it fully factored as well if you wanted. But I like this answer much better. So that's the idea. When you're dividing, you flip and multiply. Flip and multiply. Refliprical, right? Reciprocal. All sorts of good stuff. So thanks for watching, Internet friends. Bye-bye.